Hi guys, this is Dan Bentley from Section D, and I've got some general feedback from the self-assessed problem set 20.2 from week 20. So this was on complex numbers, and keeping with Mr. Stevenson, I had to get some sort of complex number jokes here, and if you wondered why they can't be together, it's complex. I just want to take us through a few question. Oh, well, we got to have another joke here. I'm going to let you figure this one out for a minute. Just see if you can get that one. Yeah, all right. Explain it to somebody around you. There you go. Okay, so for the self-assessed problem sets, one thing I want to highlight before I get into some details of a few questions is the idea of these, which most of you are doing a very good job of, but some I feel of my class are not really doing the reflective piece. So this is, I've taken this part out of your content, and when you look, you have to do all of these bullet points if you want to get a grade on this assessment. So you have made a fair attempt. You've actually graded the problem. You've given yourself a grade out of 10, so please make sure you do that. Indicate the problems you got wrong, okay? Circle it, and you can put some annotation on it. This is important, okay? So when you make some errors, please make sure you, rather than just maybe an X on it, but go ahead and in the margin write a little bit of annotation. And then here's something that a lot of people are neglecting. Okay, have you made a general reflection at the end of the paper? Okay, so if you're just quickly running through the problem set and you're not actually giving any reflective sort of feedback on it, then it's not going to be looked at as complete. Okay, so that's the point of these exercises. Please make sure you do that. Okay, and of course you are getting that to a PDF under 1.5 megabytes and sending it to your teacher before the deadline in your Dropbox. Okay, so you've got the mark scheme, and I think this was pretty straightforward. I'm going to just look at question 3, I think 8, and 10, and we'll just talk a little bit about those, and then get you on your way. So number 3, you were asked to find the values of A and B, okay, and where A and B were integers. So I think you just start multiplying through. Okay, so what you did there is you distributed through, you FOILed out, and you're looking at A and B. Now, a good technique here is to equate the real parts and the imaginary parts. Okay, so I'm looking for the real parts, and I know that that's going to be the 4a and the negative 3b, and the I squared, of course, is negative 1. So I write out my real parts, equating it to the real part. I look at my imaginary parts. I write out my imaginary parts and equate it to the imaginary parts. When I write it like this, it's not necessary to write the I there as well. We know that it's going to be imaginary. Now I've got a bit of a system of equations. I can work one equation out, and here I got an expression in terms of B. I substituted that into my other equation, and I work through to find A. Here, a good technique here, if you end up with something like this with one of the variables on the denominator, you've probably done this many times in other topics, but you can multiply through both sides by an A, giving you your favorite thing, a quadratic equation. Simplifying that and looking to factor. I think this was factorable, yep, nicely factorable. And that's what you ended up when you factored, but you noticed that it had to be an integer. So we didn't need that one. It's not an integer value. So A is 2. Subbing that back in, we found out that B was also 2. So hopefully that was pretty straightforward. The next question, question 8. Okay, you have a complex number, and we needed to express. This was a division question, and I think you know that we need to multiply by the conjugate on this. So I also want exact values, and I can't just pop this one in my calculator. So here's my conjugate. Okay, so the idea of a conjugate of the denominator. So I just changed that sign in the middle. Now, hopefully you know the shortcut there for your denominator. It's just going to be the first term plus your the square of your first term plus the square of your last term. So you probably have recognized that by now. It makes your life a lot easier. I'm going to FOIL out the numerator, and I'm going to just start simplifying. So I'm grabbing right there, I'm grabbing the real part, putting that out here first, and I'm grabbing the imaginary part, and I put that out there. And now I'm going to kind of work this through. And I think a lot of you, at least the ones I looked at in my class, realized there was a little bit of an issue in the mark scheme. Now, do we do this on purpose, or do we do it to keep you on your toes? I guess you'll never know. But yes, there was a little bit of an issue on the mark scheme with the sign on the real part. So I think that you'll have seen that there was a sign difference. So here I have written it two different ways. So I mean both are correct, but you can have here if I pulled out a plus 1/4, that left me with 1 minus root 3 there. If I pulled out a negative 1/4, that I just kind of wrote that in the way that it was showing it in the mark scheme. Okay, so hopefully that was okay. And then I've just got one more question here for you. Question 10 we're looking at. Okay, so we have z sub 1 is equal to one thing, z sub 2 equal to another thing, and then we have this expression, and we need to calculate values for a and b. So I just went ahead and did my substitution right off the bat here, and I needed to get a common denominator to add those first two. So as you've done in algebra many times before, I multiplied, if I'm going to multiply those denominators to make it a common denominator, I am responsible to multiply the numerator by whatever the denominator was multiplied, so you see that in green, and also in red there for the other term. Okay, so when I do that, I'm just going to tidy up my numerator here, tidy up my denominator, okay, and that's equal to this. Okay, so then I'm going to look through here. Now, my goal here is to find what a and b are. So I'm actually can look at the numerator and the denominator separately and see what helps me out. Here if I consider the numerator, and what if I just grab the real parts of the numerator? Will that be enough to help me find something for a? So here's my real parts of the numerator. I'm equating that to 9, because it's a real part. And a simple little algebra here gives me an a of 2. I want to get the b. I notice that b is just really my denominator. So from my denominator, what if I pulled out the real parts of my denominator? Okay, so there's the real part. Remember, I squared is negative 1, so I just have 2 minus b equals 1, and there we have it, that b equals 1. So hopefully that was okay. I think this problem set was pretty straightforward. It's just a lot of algebra. There's a lot of little places to make tiny little mistakes in dropping a negative sign or something like that, so do take care as you go through these. And yep, got to leave you with something. So you know when you see that person across the room, and you're looking for a line, there you go. You can show your math power. Alright guys, hope you're having a good week, and good luck with the rest of the complex numbers unit. Okay, take care.